In 2010, 40 turtles were reintroduced to a wetlands park. By 2017, the population had doubled. Assuming the population is growing exponentially, write a function p of t representing the population of turtles over time t. Since we're told that the population is growing exponentially, let's assume that p of t takes the form a times b to the t, where a and b are parameters we need to find, and let t represent the years since 2010. And that's a good choice to make because now we can easily write two ordered pairs, and one of them is going to work out nicely for us. We're told that in 2010, 40 turtles were reintroduced to the park. So that means that we have the data point t equals 0, p equals 40. Since t is the years since 2010, then that's 0 years. And let's see, we're told in 2017, the population had doubled. All right, well, if the initial population was 40 and the population doubled, that means our second data point is 780. Using the first data point, if t equals 0, then the population is 40. So that means that a times b to the 0 must equal 40. Any non-zero number to the 0 power is 1, so that means then that a times 1 equals 40, and so then a equals 40. So we can revise our model a little bit. P of t is 40 b to the t. Now we just need to solve for b. Using the second data point, when t is 7, p must be 80. So then 40 times b to the 7th power must equal 80. Now let's solve for b. I'll divide by 40. So then b to the 7th is equal to 2. Now remember, the population doubled over that time period, and we ended up with a 2 as the factor change. And that's not a coincidence. If the statement had said the population tripled, we should get a 3 there instead. All right, now to solve for b, well, if b to the 7th is 2, then we could use radicals. We could say then that b is the 7th root of 2. Or recall that radicals can be written with rational exponents. Or b is equal to 2 to the 1/7 power. Now I can't do that calculation in my head. Let's use a calculator. I need to find, now my calculator does not have a general root button, so I'll use the exponential form. 2 to the 1/7 power. So 2, and then x to the y here, raised to the parenthesis 1, divide 7, close the parenthesis, and hit enter. And that's 1.1041. So b is approximately 1.1041. So then putting that together, a function that models this situation is p of t is 40 times 1.1041 to the t.